Hello, I'm Param Singh. Hope you guys are doing well. In the last video, we learned that lists allow us to model data of arbitrary size. Now we are going to learn how do we design functions that consumes lists. So far in our design recipe, we have not paid much attention to what the body of a function should contain, and we have usually just taken the parameters, thought about the problem, and the other pieces of information, meaning the signature, purpose statement, examples, tests, have helped us to design the body of a function. At this point, I would like to introduce function design templates, which allow us to write the body of a function also in smaller steps, and thus will help us write recursive functions easily. So here we are saying that the body of the function that consumes list, and this is a recursive data type, must have two cases. The first case is going to define our quote unquote base case. We are going to call also this case as a non self-reference case. And then the second is going to be a self-reference case or recursive case. This design follows from the definition of the list data, which we studied in the last video. And just to recap, I would go up there for a bit. And we are saying a list is either, so it has two pieces of information. Either it is an empty list or it is a pair of head and another list. The first case is a non self-reference case because this case is not referencing to the list itself. The second case is a self-reference case because it is pointing to the same data type, the one that we are defining here. And therefore, because of these two cases, we have two function clauses. The key here is that we are going to have two different cases that we have to deal with when working with lists. So the first is the base case and the second is the recursive case. So in the base case, we are saying here's our function definition and the base case is our empty list. So this is why we write here as an empty list, and we say do, and here it's going to be some body, whatever the body we write here, that's going to come here. So nothing too fancy about it. The more interesting case is the self-reference case, where we'll again write a second clause of the function, and inside we'll pattern match the list with the head and the tail. And here we are saying do will contain two pieces of data that we have to work with. The first is the head of the list and the second is the tail of the list. So head of the list will be treated based on the data type, and mostly at the beginning we are just going to work with atomic data type as the head of the list. But the tail of list is important. Here we are enclosing the tail of the list inside the same function, the one that we are defining here. So this is very interesting, and this is because if we go up here, the list appears in this self-referential case, the one that we are defining here. And because of that, we have to wrap the tail of the data Why? Because tail itself is of type list. So here we are saying self-reference to tail of list. So since this is the same list that we are consuming, we must wrap this inside the same function that we are defining. So this f and this f are the same function. So the two pieces of data that we are left with to work with is the head of the list and f of tail of the list. All right. Another important thing to keep in mind is that when we are writing these functions, especially when we are writing this clause, we will write this as it is and we are not going to change it. We may use it in different ways depending upon what the problem is asking us to do. But we are not going to split this function apart and try to see, can I split the tail of the list further or not? This is the part of what we call as natural recursion, and we are just going to trust the natural recursion is going to work out for us. The reason natural recursion will work for us is the way we have defined the list here. It is a well-formed self-reference data definition. What we mean by well-formed is a recursive data definition in which there must be at least two cases. Okay, there could be more, but there must be at least two cases. Number one. Number two, at least one of the case must not contain self-reference. In this particular problem, this is our that case. This case has no reference to the list. And at least one of the case must have a self-reference. And in this example, we have this second case which is referencing to the list itself. So it has a self-reference. Since it is meeting these two conditions, we are saying that this is a well-formed self-reference. And this is why we have to trust the natural recursion here, that it is going to work out for us and it is not going to infinitely continue to call itself until the eternity. Let's look at the steps that we are going to follow to design our recursive function. So the general design recipe is going to be the same. We are still going to write the signature as usual, purpose statement as usual, writing our test cases, although we will discuss a little bit more detail on how to write test cases for recursive data. And then finally, we are going to write the body. And in that body, we are going to follow these 4 steps. So when we write the body, we'll list both cases like above. So we'll have 2 clauses. And once we have written the 2 clauses, the first thing we are going to do right after that is define the base case. The first clause is always going to be the base case, and we'll define that. And then next, we'll define the self-reference or recursive case. So that is this case. Once we have done those, we will test our functions, make sure they are working fine. And then if there is an opportunity to generalize them or simplify them, we'll look out for those and then call our function a complete recursive function.